welcome back to another video of H&H Express model nscale trains. Today I'm gonna start with changing how I put power on the track. I have here 7 power transformers to control the whole track, but I have more power sections than power transformers. So I'm adjusting each transformer for a reasonable speed for the train, but each train has its own speed according to the motor which is inside the locomotive. So what I'm gonna do is I'm gonna use motor drivers like this, and each motor driver has 2 outputs, so I can control 2 tracks per motor driver to put power on it and also control it individually. I'm gonna control it with an Arduino Mega, and in between the Arduino Mega I'm gonna use the input-output to control the forward and backward motion of the train and to enable that there is power on the track, and I'm gonna use this one to control the speed on each section. So let me bring you up closer and I will show you how I have wired it up, and then we will be wiring up this, and it will be multiple videos, so stay tuned and I will show you what I'm gonna do. So here you can see 6 of the 7 transformers, and they have all labels. Let me go by them. So we have downhill section 5, uphill section 8 and 9, the railway station, we have the downhill and flat section number 6, we have section number 7 and 2, and we have downhill 10. And around the corner there is another transformer which is for section number 4. So, and they are now all turned off, as you can see, and I need to regulate them per train which I want to run. So, and that is what I'm gonna change. So let me go to the computer and I'll show you which power sections there are on the track and how I'm gonna update them and how I'm gonna change them.
So here we are back at the computer, and here you can see an overview of my track layout. I gave the track some coloring so that you can easily see how the power sections are. So the beginning here on this left side, this is power section main track 1. So that's what the PWSMT01 stands for. That is power section main track 01. If we then go down, we see here that this red section is power section main track 2. Then we go into the train station where we have power section main track 03A and 03B. Then next is power section main track 4. This is here on the right hand side. And then we go into power section 5. Next is power section 6, and that will go into power section 7 and power section 8. Then we have a short power section 9, and then power section number 10. Then we go back into the train station where we have power section 11A and 11B. And then we get into the last main track power section, which is power section number 12. The switches which are in each section, the power is controlled by that section. To go to the upper deck, we have also train yard power sections. And starting here at the end, which is power section train yard 01, and then it will go into 2, 3, and the section back over the bridge is power section train yard 04. So all these power sections, they will be controlled by the board which I showed you in the beginning, and we will do the wiring next up. So this is half of the power section of the main track. These are the motor drivers which control the power on the track. This is a terminal block where the 5 volt, 12 volt and ground come in. We have here the Arduino. This one is going to control all the power sections. I have here a barrel connector which is going to be connected to this same terminal block. Then we have the input-output detectors over here, and I will need to position them in the correct way, but I need to have one for each 2 drivers, so for each 2 motor drivers, and this will be the PWM signals to control the motor drivers. On top of that, there will be some current sensoring done to detect the train. So when there is a train in the track, on that section, it will have a resistance, it draws a little bit of current, so I will put some current detection sensors in between, but that will be for a later video. For now, we're gonna wire up the power to the motor drivers, which means that this pin will be having the yellow wire, which is the 12 volt. I already removed the jumper over here because this jumper makes sure that the 5 volt, which is on the right hand side, is directly connected to the 12 volt pin, which means that this motor driver then produces a maximum of 5 volt on the output of these pins. But I'm gonna use 12 volt because that's what we use in the DC nscale. So that is what I'm gonna do. I'm gonna use these wires. I already soldered them together. So red is for the 5 volt, black is ground, and we have yellow, which will be the 12 volt. So let's do it. So that's one to go. I already did some preparation on the other ones. Okay, so that is the 5 volt. So next we're gonna put these over here. Problem is there is no screw hole in it. So I will use double-sided tape or Velcro to put them here on the board. With these there are some screw holes here, so I can put them on the board. And we have 16 pins over here, and we need 2 for each motor driver. So there will be 2, 4, 6, 8, 10, so I only need to have 2 of those to do that. And I need 4 pins for this I/O board, and so I can only address 2 of them per unit. So they will be placed in the middle over here. And then up to the left as well. So I have plenty of those available. With these I/O boards, you need to set the address. So the address will be set with these jumpers, and then I'm gonna address that in the script as well. So, but first let me take out the DuPont connectors, and I will show you how that wiring is. So I added some Velcro here to this I/O board, and I glued it together so I can still remove it when needed. So when it comes to the wiring, I'm using the color yellow, orange, red, and brown, because this is a 4-string. And I connect this side up to the Arduino. So I'm gonna put this one right in here. And that is the nscale for the I2C bus. That's the clock. That is yellow. The SDA, that's the data, is orange. Then we have the ground. And then we have VCC, which is 5V. So I'm gonna bring this over to here. I'm gonna split the 5V and the ground. I'm gonna put the pins on the Arduino. So looking at this, pin number 21 is SCL on the Arduino Mega, and pin number 20 is SDA for the I2C bus on the Arduino Mega. And then we have the 5V and the ground. The 5V is this pin here on the Arduino, and the ground is at this end. So I will tuck these cables away so that it's going to be tightened up. So that is how I connect this one. The next one, I can use the other DuPont connectors for actually this one, which has pins and a male, this is a male and a female, and then interconnect them. What I can also do is I can add this one over here so that I have these 4 connected. So that is what I'm going to do, but now these I/O ports have the same address, so we need to change that address, and the addressing can be found in the documentation. So now that the addresses are set correctly, we're going to connect the I/O pins and looking at it, this is pin 0, 1, 2, 3, up to 7. So we're gonna connect this pin to this pin over here on the motor driver, and this pin to that pin of this first I/O. I can do the same with the other one, but I will do that offline. Then I have this controller. This is a servo driver controller. The let me see, BCA 6985, and the yellow pin is the pulse width modulation pin, which is going to be connected to the instead of the jumpers which are placed here, for the enable pin. If I don't remove the enable pin and I'm gonna put a 1 or a 0 on these two pins, then just the 12 volt will go out on this side or that side, depending on which one is connected. So I will finish this wiring offline, and in the next video I will show you how the programming is done to control the speed on this motor driver with an Arduino, and then you can see the rest as well as a completed array. So thank you for watching. If you want to see more of these videos, please consider to subscribe to my channel. Hit the like button if you like this video, and I will see you in a next video. Thank you and goodbye.